students. In the series circuit, the resultant or combined resistance of the circuit is equal to the sum of the individual resistances connected in series. So let's to derive the formula for the resultant resistance in the series circuit, we should keep in mind that there is a potential difference across each resistance connected, because due to the which will depend upon the resistance of the conductor resistor connected there. So the total sum of the potential difference across these across the resistance connected in series will be equal to the supplied voltage to the circuit. And there will be a second point that should be kept in mind, that the same current will flow through the all resistances connected in a series. So let's start with the deriving the formula for this. So we have two resistances R1 and R2 which are connected to the battery of voltage V, and I current is flowing through the circuit. The same current will flow through both the resistors R1 and R2. The potential difference, as I told you, there is a potential difference across R1 is as per I into R1, and across R2 it is V2 is equal to I into R2, because the same current is flowing through them, so we have taken I as the same. And so as per point which I have told you, that the sum of potential differences across these two resistance will be equal to the supplied voltage. So V is equal to V1 plus V2. So when we apply Ohm law here, so the total, suppose I is the total current flowing in the circuit and R is the resultant resistance. So IR is equal to V1 is equal to I into R1 plus potential difference across R2 is I into R2. So cancelling I on both sides, we get R is equal to R1 plus R2. Means the resultant resistance in the series circuit is the sum of the individual resistances. So this way we get the formula. So now we come to the resistances which are connected in parallel. As I have told you, that when resistances are connected in parallel, they are connected between 2 points A and B, between 2 points. So in the resistances when connected in parallel, the total resistance of the circuit get reduced, and it is smaller than the smallest resistor connected in the circuit. It is even smaller than the smallest resistor connected in the circuit. So here you can say we have a two resistors, 6 ohm and 12 ohm, when they are connected in parallel. So here we are applying this formula 1 upon R is equal to 1. So we get the resistance as a 4. So according to definition of law of resistors which are connected in parallel, so the reciprocal of the resultant or combined resistance of all the resistance connected in parallel is equal to reciprocal of all individual resistances which are connected in parallel. So this way we get the formula 1 upon R is equal to 1 upon R1 plus R2. This is the resultant resistance of the parallel circuit. So let's see here. So before deriving this formula 1 upon R is equal to 1 upon R1 plus R2, we should have 2 points in mind. One is that because there will be you can say division of current I1 will flow through R1 and I2 will be flow through R2 depending upon the resistance, but the combined current flowing through the circuit will be equal to I1 and